And finally, to cap it all off, here we are. Let's make one of many choices. We've learned simple selection, we've learned compounding, we've learned nesting. Now we're going to learn how to stretch that selection into an infinite number of possibilities. Now, of course, this stems from the fact that the world is not black and white. In fact, quite the opposite. The world is really a matter of shades of gray. We're often faced with many more than two choices. Now, give you a simple example. Imagine you're playing a game like the original Super Mario Brothers. At any given time, you could press any one of those buttons to do things like walk right, walk left, jump, duck, throw fireballs, climb things. All these different actions occur, and they're choices you are making. Your program is detecting your choice by inputs you do on the controller and causing other code to execute. So somewhere in its program it's saying, did the user choose the jump button? Did the user hit the left button? Did the user hit the right button? It's doing all those different checks, and then it's going to execute an action based on whichever one you chose at that moment, at that 1/30th of a second or however fast the game runs. Okay, so that's the general goal. How are we actually going to do it? Well, let's think about what we've learned so far. We've learned if statements, which is just one choice or the standard path. We've learned if-else statements, which is one of two choices, either go left or go right. Now what we're going to learn today is two things. We're going to learn if-else-if statements and switch statements. Now, the thing is they basically both do the same thing, but they do it in different ways. And there's pros and cons to both. We're going to get into those. So let's take a look at this. Multi-selection. Option number one, your if-else-if statements. This is going to be the predominant one you use. And this one can do everything that the switch statement can do, but not necessarily as well. The switch statement cannot do everything that the if-else-if statement can do. So let's take a look at the if-else-if statement. First up, we remember the syntax for an if statement. It looks something like, where's my stuff? It looks something like this. If some condition is true, we're going to execute the code inside. Block of code to execute if this condition is true. If it is not true, well, then we usually have our else case, if you recall. And the else case was our kind of like our safety net or our catch-all. Basically, it means if it did not go into the if statement, do this one instead. So there's our else case. The block of code to execute if all the above actions are false. Sorry about that. So we have our if condition, we have our else. You notice I have a big block of stuff in the middle, a big empty chunk. You can think of this almost like a sandwich. We have our if on the top and we have our else on the bottom. Well, what goes in between? What's the meat? Well, the meat are all of our other choices. So we see 2 on the screen. Let's add more. We can add a third choice. Else if condition 2. Now this is the block of code that's going to execute if all of the above conditions are false and this condition is true. So that means condition 1 has to fail for this one to even be tested. Condition 3 is the same idea. Condition 1 and 2 both have to fail for condition 3 to even be tested. What this tells us is that the code tests each one at a time from top to bottom until it gets into one of them. And once it gets into one of them, it's going to execute all the code in that chunk, and then it's going to jump out of the entire if structure, the entire thing. It's going to go right past the else case. So even if it gets into the first one, if it gets into this first condition, it's going to execute all the code in here, then it's going to jump out all the way around and go outside and below that else case. Okay, so what does an actual program look like? Let's take a look. Imagine I have a variable called hour, which is 5. Hopefully you remember this from the previous lessons. And I have a greeting that says hi. Okay. Well, if hour is less than 10, I'm going to change that greeting to good morning because it's earlier than 10 a.m. Okay. So if it's less than 10, it's going to change to good morning. However, if it's less than 20, which is 8 p.m., I think, yes, 8 p.m., then we're going to change it to good day. Otherwise, we're changing it to good evening. So we have 3 possibilities here. We have our first test. If it's less than 10, change it to good morning. If it's less than 20, change it to good day. If it's neither of those, change it to good evening. Now I want you to look at this code for a second, and what do you notice? This number 5, well, it's both less than 10 and it's less than 20. Huh. Well, remember how this works. It's going to go down from top to bottom, and it's going to enter the first one that it sees that's true. In this case, 5 is less than 10, so it's going to come in here, and it's going to set greeting equal to good morning, and then it's going to jump out and move on with the rest of the program. And it's going to display that greeting on the screen. If we change that 5 to, say, a 15, oops, where's my pencil? If I change this 5 to a 15, well, that changes everything. It's going to fail the first test, but it's going to pass the second test. So let's follow the logic. It creates the variable, tests to see whether hour is less than 10. It fails that, so it jumps down, and it's going to test this guy. Is hour less than 20? Yes, it is. So it's going to go in, and it's going to execute all this code. And when it's done executing that code, it's going to skip over the else code and go right down to the console.write line. Okay? So as soon as it gets into one of them, that's enough. There we go. Eraser. Trying to clean this up. So when we look at all this, how this actually works, in the original case, when we see this, it created the variable, tested if hour is less than 10. It is. 5 is less than 10. It came in, it executed the code, finished executing all the code. Remember, it could be more than one line, could be a billion lines, we don't know. And then when it's all done, it's going to skip over the entire chunk down here and continue on with the rest of the program. So it always goes into the first one that's true, and then it skips all other options. Those are two of the most important things to remember about multi-selection with the if-else-if statements. It goes into the first one that's true and skips over the rest. So that means that it actually has to scan through each one of these. If this reminds you of anything from previously in the course, it should remind you of how a hard drive accesses data. It has to scan through all of the data until it gets to the correct one, which is inherently slow. That's not necessarily good, but it does do the job. It does do the job. Oh, good. I do have an undo on my button. Okay, so let's move on. A few notes, most of which I've already covered. Only the first test condition to evaluate to true will be executed. All others will be skipped, even if they are true. Order of test condition matters. Of course it does. Since the first one to be true, is the one that gets executed, if you don't put things in the right order, you may get unintended consequences. Again, we're going to look at the next slide to see how that works out. So this can sometimes be avoided by using compound test conditions. So if you create ranges, and I'll show you that in a second. Each if-else-if statement has only one if, it has only one else, and it has as many else-ifs as we want. So what you need to realize is that basically an if-else statement is just a special case of an if statement. It's an if with an optional else. An if-else-if statement is, again, just an if statement with optional else-if cases and an optional else case. All of those are just add-ons to the basics that is an if statement. So let's look at this code for a second. It's exactly what we were looking at, but I've changed something. What would be the output of the following code here? I want you to pause the video for a second and go take a look at this. Trace through the code from top to bottom and tell me what the output's going to be. Okay, so let's assume you're back now. Let's go through the code. We create a variable and we set its value to 5. We create another variable, we set its value to high. And we're going to test the value hour to see if it's less than 20. Yes, it is. It's going to come in and it's going to set greeting to good day. And then it's going to skip over the rest and output good day on the screen. Is that what we actually want though? Is that what we intended? Well, no, it's 5 o'clock in the morning. We shouldn't be putting good day, we should be putting good morning. So what did I change? All I changed was the order of these first two comparisons. It used to be 10 here and 20 here. But that's changed now. So why does it make a difference? Well, it makes a difference because order matters. It's going to go into the first one that's true. Now, how can we adjust for this? How can we fix this? Well, how can we make our if-else if statements don't care about order? Well, we could use ranges. So for example, I could change this one to make sure the code works as intended. I could change this one to be something like if hour is greater than or equal to 10 and hour is less than 20. Now, if that is the case, if that's a range instead of just that flat value, that means that first check would not have gone in there. It would have failed that if statement because hour is 5, and then it would have correctly went into the next one. So you can see that we can ignore order if we set up ranges, but that's really not a very clean way to go. It's better to set up good ordering. That way your code itself will flow in a logical path. And then you don't have to have all these compound statements. You could have the way it was on the previous slide. Right here, we're saying, well, check before 10. If it fails before 10, check before 20. If it fails before 20, then go to the safety net, go to the else case. All right, so this is a logical path. We don't have to add any extra compounding to create ranges. Ranges are something that you should try to avoid if you can, but it's not always going to be possible to do so. It depends on the program. Okay, so let's test your knowledge. Again, I want you to pause the program and I want you to follow through with this. I want you to look at both of these programs and do a test. Do both of these tests. In yellow, we have number 2, so the number is going to start at 2, and red number is going to start at -2. Now look at these two programs and see how they differ. Now go try it out. I'll wait for you here. Okay, so let's follow through. So let's start at this first one here. We're going to say number has a value of 2. It's going to come in and it's going to say, all right, is 2 less than 0? No, it's not. So it's going to jump past this and it's going to test this next case. Is 2 greater than 0? Yes, it is. So it's going to come in and it's going to execute this. So we're going to say 2 times 2, which gives us 4. And then we're going to store 4 into number. So our result here for test 1 is 4. Now let's go over here. Let's do test 1 on this side. So remember, the number has a value 2. It comes in and it says, is 2 less than 0? No, it's not. So it skips this and checks the next one. Is 2 greater than 0? Yep, certainly is. And it comes in and we get 2 times 2, which gives us 4, which then gets stored back into number. So test 1 also gives a 4 on this side. Okay, great. Now let's try test 2. So test 2 in the red pen here, it's going to come down. Now remember, test 2 here is a -2. So it's going to come down. It's going to say, is -2 less than 0? Yeah, it certainly is. It's going to come in and it's going to execute this line of code. So we have -2 times -1. That, of course, gives us a 2. And then it's going to jump out past this code and continue on with the rest of the program. So our test 2, the value of number is a 2. Okay. Over here, let's do the same thing. So, is -2 less than 2? Yep, sure is. Comes in, it executes this, so we have -2, and we end up with a +2, and that gets stored in a number. Now the program continues down. Oh, I have to check this. That's an if statement. Is 2 greater than 0? Yeah, it is. So it's going to go in here, and it's going to execute this code. So now we have 2 times 2, and again, that's 4. So 4 gets stored in here, so the same value is going to get stored in number. So test 2 is 4. Now look at this. We got different results for that number. This code looks pretty much identical. What's the problem here? What could possibly be the problem? Well, look at the difference here. In this case, we're saying if, else if. And the rule for an if, else if is that it only ever executes one of these. If it goes in the first one, it's going to skip the second one. If it goes in the second one, it already skipped the first one. But over here, we have two separate if statements. So no matter what, it's always going to test them both. So that means for that -2, because inside of this code it changed it to a +2, well, this code actually evaluated true. This test actually evaluated true. So it executed both actions. It actually executed both operations, which may not be our intent, but it may also be our intent depending on the program. So this is the difference between having two separate if statements versus an if-else if statement. This is considered one big statement, and only one section of it is ever going to be executed at one time. Whereas over here, these are all separate and distinct statements. They are all going to execute no matter what. Well, they're all going to be tested no matter what. So that's the difference between an if-else if and multiple if statements. Now, there may be scenarios where you want both. So I'll give you an example. Let's say you're creating a video game and you want your character to be able to run forward. Okay. So maybe they can run forward or they can run left. So you might have an if check that says, if they're holding the right button, move forward. Else, if they're holding the left button, move left. If you were to write the code like this, if you're holding the right button, move right. If you're holding the left button, move left. What if you're holding both buttons at the same time? Well, in this scenario, it's going to continue moving right because the right gets checked before the left. In this scenario, the character's not going to move at all because it's going to say move right and move left, which means they cancel each other out. So you get two different situations. However, what if you want to move on a diagonal? What if this is move right and move up? Well, in this case, you can never move right and up at the same time in this first test. You can only move right or you can move up. However, over here, you can move right and up. That means you can move on a diagonal. So it depends on what your goal is. Maybe that is something you want. Maybe it isn't. Depends on the program. Oops. Yes, I suppose I did do those animations. Moving on. Option 2, multi-selection using switch statements. So a switch statement performs basically the same operation as an if-else if statement. It compares a whole bunch of options and chooses one of them, but it does so in a very different way. Now, it has some benefits, it has some drawbacks when we compare it to that, so let's figure out why. First of all, rather than checking every possible option from the top to bottom, like in order, like an if-else if statement, it doesn't do that. It actually it automatically jumps to the correct one. It doesn't scan and go through each one. It just goes directly to the correct one. Now, I mentioned that if-else if statements kind of worked like a hard drive where you had to scan through until you get to the right spot. Switch statements act just like RAM does. It has direct access, so it just directly jumps to the correct spot. How does it do that? Well, it has kind of like in the behind the scenes, it basically has like a lookup table, like a table of contents, and it says when I see this value, go here. When I see that value, go there. It doesn't have to scan through anything. It just automatically maps to the correct spot. That's why it works just like RAM. So how does it achieve such a thing? How does it know where to go? Well, it does this because it gives us limitations and restrictions on how we can format our switch statements. So to achieve this super speed, which switch statements are limited in what and how they can compare data. First and foremost, you can only ever check equality. Exactly equal to. You can't check less than, you can't check greater than, you can't check less than or equal to or greater than or equal to. You can only check equal to, which means ranges are impossible using switch statements in C#. In some other languages you can fake it, like Java you can fake it. C# you cannot fake it. You can only check exactly equal to. Okay? So it can be, it's not meant for situations where you want to check is the number 4, is the number 5, is the number 6, is the number 7, because you'd have to active check each one of those individually, and it would just be cumbersome. You might as well create an if-else if statement in that case. It doesn't make any sense. So the first thing is that you can only check equality. The next thing is that you can only check certain types of data, ints, bytes, and strings. That's it. So those are your major restrictions. You have to check equality against an actual value that's either an int, byte, or string. All right, so what does it actually look like? Well, here's your general syntax. We have switch and then some variable. an opening and closing bracket, you'll notice that there's no other brackets in the entire structure. The only brackets are around the switch. Inside, we have different cases. And the reason why they use that case, well, basically, it tries to relate it more to English. So, for example, you might, when you're talking about making choices in life, you might say, well, in this case, I'm going to go down this path. In that case, I'm going to go down that other path over there. It's just to try and relate it back more to English so you can read it more clearly. So basically what we're saying is, when we look at this setup, case value 1, we're saying, is variable equal value 1? Is it exactly equal to value 1? If it is, execute all the code in here. I'll come back to what that break statement means in a second. Case value 2. So this is checking to see whether variable is equal to value 2. And then variable equal to value 3. And then this default thing. Okay, so let's break down what each of these mean. First of all, the break statement means get out. It means exit the current control structure you're in. In this case, the control structure is a switch statement. So that means it's going to execute all the code above the break statement. When it sees the break, it's going to jump out and go on with the rest of the program. What this basically does is it simulates the same thing that we saw with the if-else-if statement, where it says, as soon as I'm done executing my code in my section, skip over the rest of them. That's all it does. It basically simulates that exact same thing. Okay. Where did that go? Okay. So then we have all these different options. As I said, the break statement basically simulates that other thing. The break statement is required. You must have a break statement at the end of every single case, and it does have to be at the end. Okay. The last thing you see here is this default option. Now this is an optional thing. You don't actually have to have a default statement, a default case as it were. Think of it just like an else case in an if statement. It's your safety net. It means if the variable doesn't match any of the values to test, then go into this section. But again, it's optional. If you think you've covered all your bases with your values, then you don't necessarily need it. But just in case. One of the most common operations that we see for switch statements is things like menus, because menus can typically have a whole bunch of options. So the example over here demonstrates this. So I have a string variable called menu option, and I'm reading that in from the user, and I'm going to do a switch statement on that variable. And I'm going to check for 3 possible inputs, X, C, and F. Whenever I see an X, I'm going to tell the user, well, it's time to exit the game, exiting game. This is just a demo program. This is not really a useful program, by the way. Anyways, so whenever we see X, you'll notice that I'm saying, is this exactly equal to that exact value? That's why these are values. They're not variables, they are values, the literal values. Is menu option equal to quote X? If it is, it's going to come in here and it's going to output this line of code and then break and get out of the whole thing. If the user enters a C, we're going to tell them to continue playing. And then if they enter an F, we're going to say, well, you're forfeiting the game. You're quitting. So we have exiting, continue, and forfeiting. 3 options. Now, depending on what the user enters in, if they enter in a P, it's not going to go into any one of those. It's going to go into our default case, which we can say invalid menu option. So this is one of the reasons that a switch statement is so useful as a menu, because in most programs, menus are massive. In text-based programs, they're not huge usually, but if you think about the logic behind a menu in something like Microsoft Word, just think of how many different options there are in that menu. Hundreds of things. So their switch statement in here would have 100 different cases or more. But the thing is, because switch statements are so fast, it wouldn't make a difference. Whereas if you had an if-else-if statement with 100 different options, well, it would have to scan through every single one of those until it got to the right one. It would still functionally work, but it wouldn't be as effective. It wouldn't be as fast. So there's that. And then the other thing is the cleanliness of the code itself. You look at this. This is very clean and neat. It's very easy to read. It's very easy to follow. If-else-if statements are usually fine, but sometimes they can get big and cumbersome. And we're going to see an example of that shortly. So this is what we're looking at for our a menu, very typical menu. So a couple quick notes that I've already stated, but I'm going to state one more time just to drill it in. Number one, the break statement will exit the switch statement when it's executed. This simulates the idea of only entering one of the test conditions in an if-else if statement and skipping the rest. Great. A break statement is required in C#. Other languages, you actually don't have to have it, like Java. But that creates an entirely different set of problems. We're not going to cover that in here because we're not covering that language in this. And then finally, the default case is an optional thing. And it acts just like an else statement and an if-else if statement. No difference. That's all it does. Okay. We're almost done. So how do you know when to use a switch statement over an if-else if statement? Well, it all depends on what program you're building. The properties of a switch statement, because of the properties of a switch statement, you should use it in these scenarios. When you're not dealing with ranges of data. You can't do it other than manually coding in every possibility, which is a terrible plan, because not only do you have to code in every case, you also have to have it reduplicate all that logic in those cases. That's a terrible idea, and you shouldn't do it. Number two, when you have a lot of options or an expandable set of options, maybe more options are going to be added later, it's really easy to just add another case in your switch statement. All right, and when you have a lot of options, the reason why you're doing this is because of that direct instantaneous access. So if you have 1,000 options, it's just as fast as if you had one option. Whereas with an if-else if statement, if you had 1,000 options, well, it all depends on where the testing data you're looking for lies. The worst case scenario is that it's not there at all and it has to go to the else case and it has to check through all of them to get to there. Whereas in a switch statement, the worst case scenario of it not being there is just as fast as it actually being there. It still takes one movement, go directly to that point. That's it. So the next time the other time you would need this ties right into that when speed is a necessity. So of course, if it's instantaneous access, it's a lot faster than if you're scanning. When you want to clean up your code, okay? So depending on what it looks like, depending on how complex your if-else if statement is, a lot of times a switch statement can clean that code right up and make it look a lot prettier than you would think. So what you're going to find on our class website is a few comparison sheets that is going to compare the different type of structures. And in there, you're going to be able to see how neat and tidy a switch statement can be even if it's the exact same logic. So there's two main reasons to use a switch statement over an if-else if statement. Number one is speed, and number two is readability. Okay, that's what it usually breaks down to, efficiency and readability. Okay, so that's the end. That marks the end of our selection unit. Go on and try what practice work we have ready for you, and good luck.